Lesson 23 is going to wrap up topic B for us. And what we've been really working on is graphing linear equations and writing equations given a graph. So the defining equation of a line is standard form. Oh, let's change color here. Standard form, I guess it's just the defining equation of a line. It's how we can write linear equations. No, it's not the best way maybe to graph it, but it's a form we can put everything in and then compare things. And that's what we'll be doing in this lesson. So standard form, remember, is a times x plus b times y equals c. Now, a, b, and c are integers. Now remember, integers are positive and negative whole numbers, including 0. So anything on a number line, -7, -6, -5, -4, all the way up to positive 350, I don't know, keep going those, but no fractions, no decimals. So this, and this are all integers. And the other thing we have to remember is a is not negative. Okay, so we're going to be working on this form and doing different things with it, comparing different equations. So let's sketch the graph of the equation 9x plus 3y equals 18 using intercepts. So this will be good review about how to graph using intercepts. Remember, when we use intercepts, we're going to substitute 0 in for x, and we're going to substitute 0 in for y. So we're going to go through this equation twice, inputting a 0 one time for the x and the next time for the y. So this equation right here is 9, instead of saying times x, I'm going to go 9 times 0 plus 3y equals 18. Now 9 times 0 is just 0, so I'm left with this positive 3y equals 18. This is 3 times y, so I'm going to divide both sides by 3. And y is equal to 6. So remember, we can go to our y-axis at 6 and put it at, or remember this is the ordered pair 0, because that's your x value, 6. And if you graph 0, 6, same spot. Okay? So now we're going to do this again, but this time we're going to put 0 in for y. So I'm going to say 9 times x plus 3 times 0 equals 18. 3 times 0 cancels out, and I'm left with 9x equals 18, and I'm going to divide both sides by 9, and x equals 2. So I can go to my x-axis at 2 and put a dot, or think of this as the point 2, 0, which ends up right there. So it really doesn't matter. Then we'll draw a line through them. Okay, and remember, that line represents all the possible pairings of x and y values that make this equation a true statement. Okay, so now it says, part A here, sketch the graph of the equation y equals -3x plus 6 on the same coordinate plane. So I'll change colors here. And remember, this is slope-intercept form. Y equals m times x plus b. So our slope is the m, which in this case is -3. So I'm going to write it as -3 over 1 because slope is rise over run. And my y-intercept is whatever is being added on, that b value. In this case, it's 6. So remember that when we go to graph and slope-intercept form, we had like 3 steps. The first step was plot your y-intercept. So I go to my y-axis and put a dot there, and apply your slope. So from here, I'm going to rise -3. That means I'm going to go down 3 and run 1. I can do it again. Go down 3, run 1, and then I'm going to draw a line through there. And what do you notice about these graphs? Well, they're the same. Okay, I notice that they're the same line. Why? They go through the same points. Because remember, we started with this y-intercept of 6, okay? And although the first time through we did -3 over 1, or down 3 over 1, it's on the same line, it wasn't the same point, we did it again. Went through the same point. So if you're going to have at least 2 points, it's going to give us the same line. Now, notice this bottom part here. It says rewrite this in standard form. So remember, Standard form means I got to get my x and y to the left side of my equal sign. I got to make sure a, b, and c, coefficients of x and y and what it's equal to, are integers. And we got to make sure that a is not negative. So we did this a few lessons ago. So what I'm going to do is I'm going to get rid of my x term on the right. So it's a negative 3x, so I'm going to do a positive 3x. Whatever I do to one side, I do to the other. Remember, this is y plus 3x, so we could also think of this as 3x plus y equals, that gives me 0, 6. And, well, that's it. Integer, there's an integer, it's a 1 right here, and then we have our 6 right here. So that's it. Written pretty sloppy, but 3 times x plus y equals 6. Okay, so identify the constants a, b, and c of the equation in standard form. All right, so what we just came up with was 3 times x plus y, I'll put it as 1y, equals 6. So remember, standard form is ax plus by equals 6. So the constants a, b, and c, well, a is 3, b is 1, and c, oops, sorry, I'm sure you probably caught that, c is 6. All right, so now it says identify the constants of the equation 9x plus 3y equals 18. Well, that was the first one we did. And these little marks here, we represent that as prime. This is a prime, b prime, c prime. So a prime right here is 9. B prime is 3. And c prime is 18. All right, so we're just identifying those things. And then it says, well, what do you notice about a prime over a, b prime over b, and c prime over c? Okay, well, if I take a prime here, which is 9, and I divide it by a, which is 3, I get, well, 9 divided by 3 is 3. If I do b prime over b, b prime is 3, b is 1. Well, 3 divided by 1 is 3. And if I do c prime over c, that's 18 divided by c, which is 6. And guess what 18 divided by 6 is? 3. Okay, so remember, to wrap this whole problem up here, we first graphed using intercepts. Then we did this other linear equation here, and we realized it was the same line. So we would think it would be the same equation, except it wasn't. But what we found about the coefficients is that they're basically all multiplied by 3, right? If I have 3x plus y, well, 3 times 3 is 9. 1y here, well, 1 times 3 is 3. 6 here, 6 times 3 is 18. And that's why when we talk about the defining equation of a line, the standard form, when you can multiply each of those coefficients in standard form, you can write an equivalent equation, which will be helpful later on in math.